So let's now have a look at this index thing in practice and understand the impact they have and how we can create indexes. For this, you should have a running MongoDB server. I have that in a second tab. And then you find a starting dataset attached to this video, the persons.json file. Download that file and store it somewhere on your machine, and then navigate in the terminal or command prompt into that folder where you have it stored so that you can easily import it with Mongo import. So simply type Mongo import, then the path to that file. And now since I'm running this in the folder where the file is, I can just type the file name. Then the database where you want to store this, and I'll simply create a new one, contact data, and the collection which you want to create for that data, and I'll name mine contacts. Now you also need to add JSON array at the end so that this gets imported correctly, and it should import 5,000 documents. Now if you connect to your database thereafter, you should have the new contact data database, which we can use now, so contact data, and in there you should have this contacts collection. So let's now use that contacts collection. And let's first of all have a look at a single contact. For this, I'll reach out to my contacts and find one element. So this is essentially what we have in there. This is some random person data. Each person has an ID, gender, a name, which is actually a nested document, as you can see, a location, which is a nested document, even coordinates here. We got a time zone, got an email, login data, date of birth, which is both the date and the current age, some registration date. Let's say this is for a web platform where people can manage their contacts, and each contact therefore also has the date when the contact signed up, and so on. So we get this basic dummy person data which we can use. So now let's run a query and let's find all people who are older than 60. So for this, I will clear my shell here. And I will then reach out to contacts, run a find method here, and I'm looking for the dob.age field, so for this field in the embedded document. And I'll have a greater than query, and the greater than query will be looking for people older than 60. Let's also pretty print this, and we get a bunch of results. 61 is the age here, 61 again, so there are some people who are older than 60 as it seems. We can also have a look at how many results we got by adding count at the end. So 1,222. Now, of course, this was a super fast query, but we also don't have that many documents in this collection. That's important to keep in mind. Now, in order to determine whether an index can help us or to see what MongoDB actually does, MongoDB gives us a nice tool that we can use to analyze how it executed the query. And this tool is a simple method we add to our query. Here, after you reach out to the collection, you can add the explain method and then chain your normal query. Explain works for find, update, delete, not for insert. So it basically works for the methods where you, narrow down documents, where you find documents. And then here we can, of course, repeat our condition, looking for dob age to be greater than 60. Now here we get the detailed description of what MongoDB did and how it derived our results. MongoDB thinks in so-called plans, and plans are simply alternatives it considers for executing that query. In the end, it will find a winning plan, and I'll come back to how MongoDB determines this later. And that winning plan is essentially what it did to get our results. And you see here the winning plan was to do a full collection scan. We could also have rejected plans, but for this we would need alternatives, and without indexes, a full scan is always the only thing MongoDB can do, so there were no alternatives, and therefore the only approach we had, of course, is the winning plan. Now we can get even more detailed output by rerunning that command, but now we can pass an argument to explain. And that argument is a string where we control the verbosity of this command. If you pass execution stats here, and make sure you get that typed correctly with a capital S and a lowercase e, you find a detailed output for this query and how the results were returned. There, you see that the overall query took 5 milliseconds, which is of course super fast, but our collection is also not very big. And if it were bigger, if it had millions of documents, this number would of course scale up. And you see that we had to look at 5,000 documents in order to return our 1,222. So there's quite a big gap here. And this already is a sign that this is a kind of an inefficient query. Now let's add an index and see how this changes things. We do add an index to a collection by typing dbcontacts and then create index. Now an index is defined as a document here, and the first value, the key here, is the name of the field you want to create an index on. And in my case, that is dob.h. So you see you can create indexes on embedded fields just as you could use a normal field. So you can use top level fields, you can use embedded fields, doesn't matter. Then the value is whether MongoDB should create that list of values in that h field in an ascending or descending order. So it can sort by ascending or descending order. If you add a 1 here, it'll be ascending order, so lower values come first, higher values towards the end. If you add a -1 here, it's descending. What you choose here, in the end, doesn't matter too much. Even if you do sort your results and you sort in the opposite direction, it will still be sped up because MongoDB can traverse that index in both directions. So you can actually choose what you want here, and I'll go for ascending. Now this created an index. You see we had 1 before. We'll see which index that was in a second. Now we have 2. So with that, let's repeat our explain command here for people older than 60. And if we do that, we should see that now the execution time is down significantly from 5 to 3. So obviously we're talking about small numbers here, but the main thing is it was sped up. We also see that there are 2 execution stages now. And we also see that the first stage, the input stage, was an index scan. In the other output, that would be our winning plan essentially. So it did not do a full collection scan, but instead an index scan. And there you see that it returned 1,222 documents, or not documents to be precise, but keys in the index with their respective pointers at documents. So the index scan does not return the documents, but just the keys in the index and the pointers to the documents. It's the next stage, the fetch stage, which will then take these pointers returned from the index and reach out to the actual collection and then fetch the real documents from there. And therefore, in the end, we see here, we had to only look at 1,222 keys in our index to reach 1,222 documents which are returned. We also had to look at these documents because the index only has the pointers at the documents, so the index just narrows down the set. We still have to go to the collection and get the documents from there to return them in the end. But this sped up our query, and this is how our index can help us. Now, before we dive deeper into the different types of indexes, let me also show you something interesting about this dataset, which helps you understand indexes a bit better.